My name is Ashish, and I'm working with Dr. Reza on TransferFi. What we're doing is we're creating a long-range, safe, and efficient wireless power transfer network. Now, our vision as a company is to provide access to power to anyone, anywhere, at any time. Power has pretty much been the backbone for every industrial revolution. First, steam engine, second, AC distribution, third, inverter control systems. Now we are in the fourth industrial revolution where we're looking at focusing on a digital economy, turning this physical space around us into a digital economy and also autonomy. This requires mass sensor deployments and also requires a way to be able to deploy this in scale. So wiring technology or batteries cannot get us there. So wireless power transfer is a way forward to be able to get to the next industrial revolution. Now, back in the day, I used to work in a fully automated manufacturing line. We had to install 800 sensors, which required miles of cable spaghetti, $1 million installation costs, and also 2 months to deploy the whole system, which was a huge problem for the company. With wireless power transfer, you can remove cabling entirely, reduce costs by 50%, and reduce deployment time by 80%, which is a huge thing that cannot be ignored by any industrial company right now. Now, overall, on average, for any industrial IoT deployment, more than 60% of the cost goes into cabling installation. All the smart stuff, like the PLCs and programming, is less than 40%. Now, wireless power transfer is going to disrupt the 62% and make industrial IoT a lot more scalable down the road. We already have systems deployed. We have the gateway and the sense units, basically powering up these sense units at 55 meters, but also we handle data as well. So it makes it a lot simpler to be able to install this whole system and seamless. It was featured in National Geographic. We have 3 patents filed, 3 more patents to go. So a lot of innovation that's being involved in this particular system here. And this is all real, it's been deployed. As you can see over here, this is our smart building case study. Basically, 3,000 sensors are expected for this one, but this is just a small deployment to showcase the value. 3 things to showcase: robustness, reliability, and also the air quality. We've actually been up for 99.96% of the time for 5 months now. What's amazing is that there's a massive cost savings. Traditionally, to cable this, $1,000 per sensor. With wireless power transfer, looking at $120 per sensor just in installation. And in 3,000 sensors, we're talking about more than $2.6 million worth of savings, which is something, again, cannot be ignored. Now, this is for predictive maintenance. Now, this over here is an oil and gas manufacturing line where they are actually creating pipelines. Now, each pipe costs around $50,000 to $200,000 depending on materials. Now, the technician previously was actually holding the bearing, putting a hand there to understand the anomalies in vibration or any anomalies in the machine and shut the machine off. So that's a lot of issues that happen. They tried batteries, this company, but the batteries only lasted 6 months, which is too much of a maintenance cost. For wiring or cabling this whole system, it would take 2 days, and minimum $2.4 million would be wasted in just cabling. So we deployed this system in 30 minutes, and we were able to get vibration analysis data, and all fault detection is required without even interrupting the workers whatsoever or any technicians. The machines are still running, so not evasive entirely. So here's a bit of cost as to how this makes sense. Well, if you look at different operational or lifetime costs of batteries, cables, and TransferFi wireless power network, as you can see, batteries type of sensors are very cheap initially. So the initial capital expenditure is quite cheap. But with 3,000 sensors at 4 milliwatts each, you have to change batteries every few years, which will then cost the cabling cost over time. And then if you add actual labor cost to maintain it, then you'll bring back further, and the crossing point will be at 4 years. If you then add like downtime, then they'll move back further, even to about 2 years. So that's a big problem. So wireless power transfer is nice. It's also cheaper than cables, but maintains its operational expenditure over time. We've also had paid pilots with multiple MNCs out there, and also they've proven our technology. Plus, we have investors from all over the world that's supporting us to move forward. And we are actually looking for our Series A round next for growth, because we're going to be manufacturing soon. This is the team. When it comes to great power comes great responsibility. As you can see, Dr. Reza, the co-founder, CTO, he spent more than 6 years, actually 7 years, in wireless power transfer optimization research, postdoc in NUS. I spent 8 years in industry focusing on embedded systems, industrial IoT, and heading regional teams. And we brought on Siddharth and Lionel, who have more than 30 years of experience within commercialization, taking products to manufacturing. And then we have Riet, Uriel, Mayang to robustify our entire system. In the future, when it comes to cable infrastructure, renewable energy, or even offshore grids, we're looking to revolutionize the way we distribute power in the future. If you have any questions, please let us know, and hopefully we can get through some answers. Thank you very much.